Okay, am I audible now? Yes. Me? Can you hear me? Okay, now as you have gone through page replacement algorithm, how many of you have actually gone through a page replacement algorithm? Yes. See, more you give the feedback, more it will be helpful for me. Otherwise, this will be a monotonous and I'll be lost somewhere during the discussion. Okay, so what we have done in unit number 5. Let's quickly give the recap. Just type the keywords which you remember and we'll go through that one by one. Quickly keep what you have seen in unit number 5. Yes, type the keyword about the memory. It's a main memory we are talking about, right? The main memory management is far more important than the secondary storage space. It's all because it is costlier, it is available in limited amount, and if you do not manage it properly, then system is going to lag or have some kind of a issue which lead to the system called as an thrashing. I've also shared some material regarding thrashing. Have you gone through that? Has anyone seen the thrashing video? So what's a thrashing? Thrashing is a concept introduced in a memory management system whenever we have every page which has been required in the demand paging. Okay, in a demand paging system, if every page which has been required by a system or by an particular process, it isn't available in a main memory or in a page table, then this will lead to ask or generate a page fault. And page faults are generating in a continuous sequence or a continuous manner will lead to a chain of requests generated for or asking that particular page from a secondary storage. Now, due to this, as we have to get a page or the data from a secondary storage, this will lead to a or keep the system waiting. Okay, microcontroller or a processor will be waiting for that particular amount of a time, and if that happens continuously, then we call it as an thrashing. Okay, thrashing happens. The better example of a thrashing is when if you had ever driven a motorbike. As how many of you have driven the motorbike? A geared motorcycle. If you have tried, then what happen if you are in gear number 3 or 4 and at the particular time you have to slow down. Okay, then what happen is the essential speed at that particular gear setting required by the motorbike is quite high than the actual speed, and you feel that the system has been struggling through the corresponding torque to be generated. At some point of a time, if you keep on doing this, the system will get halted and the motorbike will be stopped. Somewhat similar happens in a computer system. Now this is nothing but, or this is synonymous to the thrashing in a computer system where we have to drive a microcontroller or a processor continuously. Now the microprocessor has been working at a very huge speed of gigahertz, whereas the secondary storage has been working at what we say at a megahertz range, and all because of that the speed mismatch will be there. And if we keep on asking from a data from this lower speed to higher, this is going to be generating a system lag, and that system lag is called as an thrashing in a paging system or thrashing in a memory management system. What do you know about a optical sorry what we call it as optimal page replacement algorithm? How it works? Can anyone explain or share their thought on this? As you have gone through multiple videos on this, how a page replacement algorithm works? A page replacement algorithm works as all in when you actually have the number of page frame which have been. Okay, I'll ask the question again. How a page replacement algorithm works? Page replacement algorithm, and it's working. I'll be waiting for your comments. Okay, more you type, more you participate, more I'm able to. Yes. पर एक रफ पेज है. It replaces when one is not used in a main memory. Yes, it is. Okay. Uh, okay. I might, I might have to mirror my camera, otherwise it will not be possible for communication. See, whatever I'm typing is mirrored out. So I'll work out on this and we'll come back later. But what we know is, let's say we have a limited number of a memory unit. Okay, let's say each memory has been splitted into smallest possible chunk of a fixed size, then we call it as an page frame. This will be called as an set of page frame. Then again, the main program or the program which we want to execute on this corresponding computer again has to be sliced with the same amount of pages, like this one. If it is visible, then these are called as an page. Page will be fitted into a page frame as because they have been of a same size. Now, as you can see in this pictorial wave, the number of pages are far more as compared to the number of available page frames. Now, how it is possible to consume or complete this program if I have a limited amount of a memory? And this lead to the solution which we call as an demand paging, or you can call this as a page replacement algorithm. Now what happen is, whenever you require a particular gone नेट टिकट होते थे क्या possible? हाँ, 4-5 मिनट